Here are the 8-5 homework solutions. Again, for people new to watching the videos in 7th period, this doesn't mean that you can't ask questions about any of the problems if you still have questions. It's just a way to try and maybe speed up the process of going over the homework in class. So again, if by the end of watching this you're still confused about anything, please feel free to bring it up in class. All right, so we're going to do implicit differentiation, which basically means we use all our same derivative rules, but when we take the derivative of y, we write dy dx next to it. The reason for that is that we are essentially doing the chain rule, but even if you're still struggling to gather that idea, it doesn't change the fact that as long as you recognize when we take the derivative of y, we write dy dx next to it, you'll still be able to get these correct. So I've used my power rule to get my derivative. Don't forget the derivative of a constant is just 0. And then our goal is to isolate the dy dx. So the pieces that don't have dy dx, I'm going to move to the right-hand side of the equation. That's fairly typical, but not mandatory. And then I'm left to factor out my dy dx from the two remaining pieces. I divide both sides by the quantity being multiplied by dy dx. And then since all of these terms are divisible by 2, I am expected to simplify. Number 3, again, first step, use your power rule. Don't forget to write dy dx next to anything that has a y. Remember the derivative of negative 8y would just be negative 8, and then we include the dy dx, and the derivative of 4 gets us 0. I move my pieces that don't have dy dx. I factor out my dy dx, divide by the quantity being multiplied by dy dx, and like the last one, since all of these are divisible by 2, I am expected to simplify. Number 5, again, none of our derivative rules are changing, so on the right-hand side, I just have to remember to use my quotient rule. Use my power rule on the left, including my implicit rule for writing dy dx, and then I've got low, d high, minus high, d low, all over low, low. The algebra for my numerator would have had x plus 1 minus x plus 1, so that's why I end up with just a numerator of 2. I'm going to divide both sides by 2y, but it might be easier to think of this as multiplying by the reciprocal, right? If you divide by 2, it's the same as multiplying by 1/2. That's going to make it a little bit more obvious how I get to my value of 2 over 2y times x plus 1 quantity squared. And then again, I'm able to reduce like the first two, and I've got my final answer. Now, nothing about what the derivative represents ever changes. The derivative represents the rate of change. The derivative represents the slope of the tangent to the function. So in number 11, when I'm asked to write the equation of the tangent line, given this point, it doesn't change the fact that I need the derivative. I'm just using new derivative rules. I start my process of isolating dy dx by subtracting 2x and subtracting 6. I divide by my 2y minus 14 to get my dy dx all by itself. Now, technically, you don't have to reduce this one since the derivative isn't actually the final answer. I think it's a good idea to always have the habit of factoring so that you don't forget to, but technically you could have substituted into this original version where I hadn't divided by 2. I substitute in my x value, I substitute in my y value, and simplify. Oh, I realized I've made a mistake. So my denominator would have just been positive 1, so my derivative would have been negative 3. And whether you write it in point-slope form or you recognize that you're able to simplify it into slope-intercept form pretty quickly, that's up to you. All right, multiple choice number 5, and I think it's multiple choice number 6, rely on the fact that our derivative ends up being a fraction, and we know that our derivative, a fraction can equal 0 when the numerator equals 0, but a fraction would be undefined if the denominator, equaled 0. So I start by using my power rule. I don't forget about my implicit rule. Start moving my pieces that don't have dy dx. Like that previous problem, I can say that I'm dividing by negative 2y, but for some of us it might be a little bit easier to see it as, oh, sorry, there is no other fraction. So we'll leave it as negative 2y. So I've got my derivative. In multiple choice number 5, it asks us to figure out when our derivative has horizontal tangents. A horizontal tangent has a 0 slope. Well, what's going to make this fraction equal to 0 is when the numerator equals 0. So I substitute in, pardon me, I set my numerator equal to 0, I factor, I come up with my two x coordinates, and that's going to get me my value d. The answers are written as ordered pairs, but there's only one set of answers that has 0 and -2/3, so I don't need to keep searching for the y values. Multiple choice number 6 is very similar. Difference is I want to figure out when my derivative is undefined, or in other words, when my denominator equals 0. So I use my power rule. Don't forget about my rule around implicits. And remember, the derivative of 2 would be 0. So I subtract 2x minus 1 from both sides, divide by my -2y, and I've got my derivative. So again, this is asking when my derivative is undefined, so I'm going to set the denominator equal to 0 and solve. I get y equals 0. Unlike number 5, I've got to actually take the time to go back and plug this value in, since there's multiple answers that have y coordinate of 0. So I go back to my original function, substitute in y for 0, and start solving. In this case, I'm going to have to do some factoring. So I subtract 2 from both sides, factor my polynomial, and now I know my 2x coordinates would be -2 or 1, and so I know the ordered pairs I need, -2, 0, 1, 0. Again, I hope this helps. If it doesn't, please feel free to bring anything up in class.